Today, we are going to discuss about the limits. So let's start first with definition. We say that the limit of f of x is L as x approaches a, and write this as the limit of f of x is L as x approaches a. So that's how to read it properly. So provided we can make f of x as close to L as we want for all x sufficient close to a from both sides. So from both sides. So without actually letting x be a. Example, estimate the value of the following limits. So the limit of x squared plus 4x minus 12 all over x squared minus 2x as x approaches to 2. So take note, we're only asked to estimate the value. So in that case, class, to do this, we are just going to assume the value of x that is closer to or closest to the limit, which is now x as approaches to 2. Okay, so for example, if we are going to let x as 2.5, then we are going to substitute 2.5 to this equation, to the given expressions of the limits, which is x squared plus 4x minus 12 all over x squared minus 2x. So we assume now the value of x as approaches to 2. Shall we say x is 2.5? Now replace x or substitute x to this given. For example, we have x is 2.5, so you write there 2.5 squared plus 4 times 2.5 minus 12 all over 2.5 squared minus 2 times x. So the value now of our f of x is will be equal to 3.4. Okay, so meaning to say the given f of x is equal to the limit of x squared plus 4x minus 12 all over x squared minus 2x as x approaches to 2. So in similar manner, you have to try also another value of x. Shall we say 2.1? So if you're going to solve for that, so 2.1 squared plus 4 times 2.1 minus 12 divided by 2.1 squared minus 2.1. So if you're using your calculator, it will give you an approximate value of 3.857142,857. So I hope by these two examples that I discussed, so just continue the other assumption for the value of x. Then we have here, so if we are going to graph these values in the number line, we could say that 2.5 is to the right of x if x now is approaches to 2. Or shall we say in this form, if we have, okay, shall we say this is my number line, and this is, for example, shall we say this is now 0, this is now 1, this is 2, and this is 3, and this is on -1, and so on. Now, so we are talking about here the that x that is approaches to the value of 2. Shall we say this one? So the value of x must be approaches to 2, whether it is coming from the right of 2 or to the left of 2. So meaning to say, from the right of 2, we could have the value for, so as what I have said, so 2.5 is also an up, we let the value of x as 2.5 because it will approaches to our limit, that is x approaches to 2. Or you can also use any value, or if you like 3, then you can also use 3 if you want. Or you can use 2.9, we have 2.1, and so on. So in the left hand side, we have here the left hand side of 2, so we could use 1.5, or we can use 1.9, 1.99, and so on, as long as it will be approaches to the value of 2, but by not letting the value of x that is exactly equal to 2. Okay, so if you do this, if we are done substituting all these values of x, so if you try to less down the value of x, which is now 2.5, then you can solve for the value of f of x. Take note, I let f of x is equal to the limit of x squared plus 4x minus 12 all over x squared minus 2x as x approaches to 2. Now, based on this result, we could say that this table, it appears that the function is going to 4 as x approaches to 2. Okay, so therefore we write here the limit of x squared plus 4x minus 12 all over x squared minus 2x as x approaches 2 is equal to 4. As you can see, if the value is very much closer to the value of 2, then like for this 1.99999. So how many nines do we have there? I write 1, 2, 3, 4, 5. So there are 5 nines that I write. So it is already almost touches to the value of 2. So as you can see here, the value also is going to 4. Okay, so that's what we called as by estimation only. So as the question said, we are going to estimate the value of the limit. Okay, so the next slide is actually our solution to that. Now, we are going to discuss about the one-sided limits. When we say one-sided limits, so we're referring to either the right-handed limit or the other side, which is now the left-handed limit. Right-handed limit, we say that the limit of f of x equals L as x approaches a from the right. So the positive sign there as the exponent of a, it says that x approaches a from the right. Okay, provided we can make f of x as close to L as we want for all x, sufficiently close to a, and x is greater than a without actually letting x be a. Okay, our previous example as x approaches to 2. So, okay, when we say right-handed, we could say that we can take values that is to the right of x. For example, we have 2.5, and then we have also 2.1, 2.01. So those are values of the from the right side of the limit that is x approaches a to from the positive. Okay, the limit of x as x approaches a from the right, so the positive sign is from the right. Now on the other side, we have the left-handed limit. We say that the limit of f of x equals L as x approaches a from the left. So we use also the notation of negative sign. It means to say that it's coming from the left. So provided we can make f of x as close to L as we want for all x sufficiently close to a, and x is less than a without actually letting x be equals to a. Okay, so given a function f of x, if the limit of f of x as x approaches a from the right is equal to the limit of f of x is equal to L as x approaches a from the left, then the normal limit will exist and the limit of f of x equals L as x approaches a. So likewise, if the limit of f of x equals L as x approaches a, then the limit of f of x as x approaches a from the right is equal to the limit of f of x as x approaches a from the left is equal to L. So it means to say, class, in order for us to use this limit, we need to satisfy the two conditions. So it is now approaches from the right and this approaches from the left. Then if the two-sided limits will be equal, then it is said that the normal limit will exist. Okay, so let us analyze to the given graph. So according to the graph, we are asked to compute each of the following. So we have from A to L, but of course, we're not going to discuss at one everything. So we will choose only, for example, we have A is equal to f of negative 4. So how are we going to determine whether this function will exist or not. So in that case, class, the f of negative 4, look at the graph. So where is our f of negative 4? So this is now our f of negative 4. So this one does not exist because there is no closed dot for this value. As you can see here, this negative 4. So this one, as you can see, negative 4, then look at this one vertically. So that is now an open dot. So in order for this f of negative 4 to exist, then it should be a closed dot. Okay? So again, there is no closed dot for this value of x, and so the function does not exist at this point. Okay, take note that in order for this to exist, it should be a closed dot. Now, for example here, letter B, which is now the limit of f of x as x approaches negative 4 from the left. So the value of this, looking at this, the limit of f of x as x approaches negative 4 from the left. So this one, so the value of that, the limit of f of x as x approaches negative 4 from the left. So by looking at this, it says that the value is equal to 2, or I could say that the limit of f of x as x approaches negative 4 from the left is equal to 2. So looking at this again, so the one that I highlighted, so the coordinates there is negative 4, 2, wherein we can write the limit of f of x as x approaches negative 4 from the left is equal to 2. So this function is approaching a value of 2 as x moves in towards negative 4 from the left. So it is coming from here, from the left of negative 4. So from here, it will approach to negative 4. Okay, so that is because that is coming from the left. So that one is a function. Now for letter C, we have the limit of f of x as x approaches negative 4 from the right, meaning to say it is coming from here. Okay, so it could be, I would say that is coming from here. So going approaches to negative 4. Then if you're going to look at that, we have the value is equal to 2 as well. All right. So the function is approaching a value of 2 as x moves in towards negative 4 from the right. Okay. So in that case, that is a function. But what about letter D? We have the limit of f of x as x approaches negative 4. So as you can see, there is no exponent such as positive or negative. So meaning to say, the limit of f of x is equal to 2 as x approaches to negative 4. So in other words, class, if the answer of letter B and letter C exists, therefore the letter D will also exist. Okay, so let me write this one here in this way. So we could say that in letter B here, so we have the limit of f of x as x approaches negative 4 from the left is equal to the limit of f of x as x approaches negative 4 from the right is equal to 2. Now, according to our discussion a while ago, that this one, we have the limit of f of x as x approaches a from the from the right, and the other side, we have the limit of f of x as x approaches a from the left is equal to L. So in our example, the L there is equal to 2. Then, if the two are equal, the results of from the left and from the right, then this one, the limit of f of x is equal to L as x approaches a. So this limit now, it does exist. Okay, so we have, okay, let's go back here again. All right. So we have, let's try another one. Shall we say letter I? So letter I, we have f of 6. So where is the f of 6? So we have here, based on the graph, there is a closed dot. Okay? And the coordinates here, we have 6, 2. Okay? So in that case, class, we have f of 6 is equal to 2. Okay, and then that function will take only the y value where the closed dot is. So the y value, we know that in the ordered pair, the coordinates, we have the x and y values. So the first element is for x and the second element is for y. So therefore, we are only taking the y values. So f of 6 now is equal to 2. Since it is a closed dot, therefore we could say that it is a function. So as I have said, the function will take on the y values where the closed dot is. Okay, next is letter J. So the limit of f of x as x approaches 6 from the left. So it is coming from here, shall we say from negative 6 going to 6, or it could be start from 0, as long as any values that is coming from the left of 6. Now in that case, class, we have the function according to the graph, then the limit of f of x as x approaches 6 from the left, so the value of y there is 5. So that's, therefore you will say the limit of, I will write, okay, so for letter J, we have the limit of f of x as x approaches 6 from the left is equal to 5. So where do I get that one? That is coming from this. So the open dot we have here 6, 5. So the limit of f of x as x approaches 6 from the left is equal to 5. So where do I get that one? That is coming from this value that has an open dot. We have the ordered pair of 6, 5. So meaning the function is approaching a value of 5 as x moves in towards 6 from the left. Okay? Then for letter K, the limit of f of x as x approaches 6 from the right. So from the right, it means to say that the value of f of x as x approaches 6 from the right is also 5, meaning to say we get a value that's coming from the right. We could say 6.5, 6.7, or 7, 7.9, or 8. So as long as it is from the right of 6. Now the answer for that is still 5, because this is the point where can see, although it is an open dot. So for letter K, we have the limit of f of x as x approaches 6 from the right is also equals to 5. Now, for letter L, we have the limit of f of x as x approaches 6. So we have letter F. We have the limit of f of x as x approaches 6. So this will be equal to 5 again, based on the graph. Now, we use the graph or the fact to get this one. Okay, so our conclusion now for this, the limit exists because we follow this property that the limit of f of x as x approaches a from the right is also equal to the limit of f of x as x approaches a from the left is equal to L. So in that example from JKL, so the L there is 5, so they are the same, therefore the limits exist. Okay, so let's move on. Let's move to the properties. So first we will assume that the limit of f of x as x approaches a and the limit of g of x as x approaches a exists and c is any constant. Then property number 1, the limit of c of f of x as x approaches a is equal to c times the limit of f of x as x approaches a. So in other words, we can factor a multiplicative constant out of a limit. So you see there is a constant. Okay, so number 2, the limit of f of x plus or minus g of x as x approaches a. So it can be written now in the expanded form that is equal to the limit of f of x as x approaches a plus or minus the limit of g of x as x approaches a. So you will just use either positive or negative. It depends on the given. Now, for property number 3, we have the limit of f of x times g of x as x approaches a can be written as the limit of f of x as x approaches a times the limit of g of x as x approaches a. So that is now multiplication. Now for number 4, this is for division or the quotient. So the limit of f of x over g of x as x approaches a is equal to the limit of f of x as x approaches a all over the limit of g of x as x approaches a, provided that the limit of g of x is not equal to 0 as x approaches a. What will happen if it's 0? It makes the given function becomes undefined. That's why we have to remember this notation. The limit of g of x is not equal to 0 or else it becomes undefined. Now for number 5, so the limit of f of x raised to the power of n as x approaches a is equal to the limit of f of x as x approaches a, then quantity raised to n, where n is any real number. So in this property, n can be any real number. So when you say any real number, it could either be positive, negative, integer, fraction, irrational, the zero, or etc. So in the case that n is an integer, this rule can be taught as an extended case of number 3. Now, for example, consider the case of n equals 2. So we have here the limit of f of x as x approaches a is raised to the power of 2. So we're just going to multiply f of x twice. So therefore, the limit of f of x times f of x as x approaches a. So this is now in terms of a short method written in the exponential form, and this one is the expanded form. Okay, so we have, so this is just equal, we are just expanding that one. Okay, that's why if you that is why it becomes the limit of f of x times f of x as x approaches a. So number 6, the limit of the nth root of f of x as x approaches a equals the nth root of the limit of f of x as x approaches a. So the right hand side, we just put the limit inside. That's the only difference between the two sides. So this is just the case, a special case of the previous example. Now we have the limit of the nth root of f of x as x approaches a is equal to the limit of f of x raised to the power of 1 over n as x approaches a. So they are just, they are just the same and showing only that they are equal. Okay, for number 7, the limit of c is equal to c as x approaches a, where c there is any real number. Okay, take note of this. So if the limit of the given is equal to the same given as x approaches a, then it's just equal to a constant. Now for number 8, so the limit of x is equal to a as x approaches a, then the answer of this limit is equal to the x approaches a, because they're okay. I hope you master the difference between this number 7 and number 8. Now for number 9, the limit of x raised to n as x approaches a is equal to a raised to n. So this is how I remember the number 7 and number 8. So if the limit of the given is not equal here to where that it approaches, then the answer is a constant. Now, number 8, if the limit of the given, shall we say x is the given, so This is also x. So therefore, they are the same x. So whatever the x approaches to a certain number, then the answer is the same with that where it approaches to. Okay? So let's put that one into example, applying the properties. Okay, number one, compute the value of the following limit. Okay, did you see the difference of the statement? A while ago, I said estimate the value of the limit. So when we say estimate, we're only we do the assumption of x and solve for f of x, and by not letting the value of x that is really equal approaches to that particular value. So in this case, we are going to compute. We are no longer to estimate. So to solve for this, we have to use the properties that I have shown a while ago. So in this case, we are using the property number 2. So we are going to break up the limit into three separate limits because there are three terms. So in that case, class, I'm going to do like this. So we have the limit of 3x squared plus 5x minus 9. So we will use first the long method, but eventually I will just ask you to show your solution uh, in a shortcut form. But for now, I just want you to learn the the long method. So in this one now will be equal to the limit of 3x squared as x approaches -2 plus the limit of 5x as x approaches -2 minus the limit of -9. Not -9 because I already write minus. So the limit of 9 as x approaches -2. Now you try to use the properties that we have just discussed. So since there is a coefficient, then we are going to write the coefficient before the limit. So we have 3 times the limit of x squared as x approaches to 2 plus we have the coefficient of x is 5, so write 5 the limit of x as x approaches to -2 minus the limit of 9 as x approaches to -2. So in the first term, we are using this one. Okay, the first term we are applying this property number 1, and we are also applying this property number 2 because there are three terms. And all right, so it's only 1 and 2 we combine. And we also have, and we're also trying to apply this one. We have the exponent. Where is it? This I guess this one, number 5, because we have there the limit of 3x squared. So there's an exponent. So we are using also this property number 5. And we also have, so okay, this one also, especially for the third term, we have the limit of 9 as x approaches to -2. So we are using also that one as well as the property. So we are almost using a lot of properties in this example. Now, what is now the answer of this first term? I'm using to those properties that I have mentioned. So what is now the limit of x squared as x approaches -2? So the answer there is, I forgot the negative sign here. So -2. So the answer for the first term, we have the coefficient is 3. So we have 3 times. So this is what I'm trying to say. We have the limit of x squared, and we also have x here. That's why the value of x is equal to -2. So I'm using the property number 9. All right. So next, for the second term, I have plus 5 times the limit of x as x approaches negative 2. Since the limit of the given as x approaches negative 2, so this also, the value of that is also negative 2. So we have plus 5 times negative 2. Now for the third term, I have the limit of 9 as x approaches to negative 2. So which property are we going to use? The limit of 9 as x approaches a. So 9 there is a constant, okay, not a variable. So therefore, the limit of a constant as x approaches a, where a can be any real number. So the answer must be a constant. So in that case, we have the answer for the third term is a constant, which is actually the value of 9. So by simplifying this one, we have, uh, already I forgot the power of 2 on the first term. So the square of negative 2 is positive 4. So times 3, we have 12, plus 5 times negative 2 is negative 10, minus 9. So we have 12 minus 19. Therefore, the answer is negative 7. So that is now the answer for that. I hope you can try to follow the properties in order for you to answer that one. Now let's move to the other example. So we are asked to evaluate the following limit. So the limit of 6 minus 3z plus 10z squared all over negative 2z raised to 4 plus 7z to the power of 3 plus 1. So we are using here the quotient rule. Okay, we are trying to use the property number 4. So we can write here now. So the limit of 6 minus 3z plus 10z squared all over negative 2z raised to 4 plus 7z raised to 3 plus 1 as z approaches 1. So using the property number 4, so I can write now the limit of 6 minus 3z plus 10z squared as z approaches 1 all over the limit of negative 2z raised to 4 plus 7z cubed plus 1 as z approaches 1. Now, we're going to apply the properties. So, now what is the limit of 6 as z approaches 1? So, we have the limit of the first term. The limit of 6 as z approaches 1 is equal to 6 minus, we're trying to do the shortcut now. So we have the next term is what's the limit of negative 3z as z approaches 1. So we have negative 3 as a constant multiplier. So times the where z approaches 1, therefore it gives you negative 3 times 1. The negative 3 is the coefficient. We can write that one as negative 3, the limit of z as z approaches 1. Therefore, the limit of z as z approaches 1 is equal to 1 plus what is the limit of 10 z squared as z approaches 1. So I will write first the coefficient of 10. So that's z squared approaches 1. Therefore, it's also equal to 1 squared all over. We have the limit of negative 2z raised to 4 as z approaches 1. So I will write first the constant or the coefficient negative 2 times, we are actually taking the limit of z raised to 4 as z approaches 1. So we substitute the value of that now is 1 raised to the power of 4 plus the limit of 7z cubed. So I will write first the coefficient of 7 times what is the limit of z cubed as z approaches to 1. So that's also 1 to the third power plus what's the limit of a constant which is equivalent to 1. as z approaches 1. So therefore, the answer is 1. So by simplifying, this will give you now 6 minus 3. 3 times 1 is minus 3. 10 times 1 squared is still 10 over 1 to the fourth power is 1 times negative 2 is negative 2 plus 1 cube is 1 times 7 is 7 plus 1. So therefore 6 minus 3, we have 3 plus 10 is 13, and negative 2 plus 7 is 5, so plus 1, so we have 6. So therefore the final answer is, so the value of the given limit of 6 minus 3z plus 10z squared all over negative 2z raised to 4 plus 7z cubed plus 1 is equal to 13 over 6 as z approaches 1. Okay, so evaluate the following limit. So we're going to compute here the limit of x squared plus 4x minus 12 all over x squared minus 2x as x approaches to 2. So in this case, class, if we're going to substitute the value of x equals to 2, okay, let us try. We will check if we are going to substitute the value of x as 2, what will happen? So we have 2 squared plus 4 times 2 minus 12 all over 2 squared minus 2 times 2. So we have 4 plus 4 times 2 is 8, so 8 plus 4 is 12, so 12 minus 12 is 0, and this one is also 0. Now, if that is the result after plug in that x equals 2, then we're going to evaluate the limit since we cannot just plug in 2. Okay, so to solve for that, we can use our knowledge in factoring. So we have now, let's try to factor that one. Again, class, if you try to substitute the value of x as equal to 2, then if the result will give you 0 over 0, then you are going to solve. Meaning to say, we are going to find the factors of this before we can take the limits. So the limit now of x squared plus 4x minus 12 as x squared all over x squared minus 2x as x approaches 2. Okay, so this one, the first solution is also needed because you cannot just simply continue finding the limits without knowing it yet that the result is 0 over 0. So 0 over 0 means is indeterminate. Okay, so these are one of the forms of indeterminate. Now in that case, class, I'm going to factor the numerator. So we have, and as well as the denominator. So we have here the limit of the factor of x squared plus 4x minus 4 is equal to x plus 6 times x minus 2. So let's check. The first terms is x times x is x squared. Outer terms, x times negative 2 is negative 2x. Inner term is 6 times 6x. So combine the outer and the inner. So it gives us the middle term of 4x. Now, for the last terms, we have 6 times negative 2 is negative 12. So the factors is now correct. So the denominator is x squared minus 2x. So just use common monomial factor. So common monomial factor is x times x minus 2 as x approaches to 2. Now in that case, we're going to divide and we can use cancellation. So we have x minus 2 is cancelled as well as x minus 2 in the denominator. And so the remaining factors, we have the limit of x plus 6 over x as x approaches to 2. Now from there, that's the time you are going to substitute the value of x that is equal to 2. So we have here, we have the limit of, so if we're going to substitute, we have now 2 plus 6 over 2, and that is equal to 8 over 2 is equal to 4. So this is now the answer for the limit of x squared plus 4x minus 2 all over x squared minus 2x as x approaches to 2. Okay, take note, before you simplify the given limit, you try to solve first by substituting x is equal to 2. Now, if the result will give you indeterminate form, so one of those is 0 over 0. Evaluate the limit of 2 times the square of negative 3 plus x minus 18 all over x as x approaches 0. So to do this, I will simplify first our numerator. So I will write here the limit of 2 times the square of negative 3 plus x. We have 9 minus twice the product. So the first term is the square of the first term. So we have 9. Then the middle term is twice the product of the two terms. So negative 3 times 6 is negative 3x. So twice. That becomes now negative 6x plus the square of the last term is x squared minus 18 all over x as x approaches 0. Now simplifying this, so we can write here as the limit of 2 times 9 is 18, 2 times negative 6 is negative 12x, 2 times x squared positive x squared, then the next term is negative 18 all over x as x approaches 0. Now by simplifying, so combining like terms, so okay, this one and this one is additive inverse. So the remaining terms now, we have negative 12x plus x squared all over x as x approaches 0. So we can divide that one. So the limit now, we have to divide. So we have now negative 12 plus x as x approaches 0. So after we simplify, we are going to substitute the value of x, which is now approached to 0. So therefore, negative 12 plus 0. So the answer is negative 12. So this is now the answer of negative 12. Okay, so we have here the limit of t minus the square root of 3t plus 4 all over 4 minus t. So as t approaches 4. So in that case, class, we are going to rationalize our numerator. So in rationalizing, so we multiply the numerator according to its conjugate. So the conjugate of t minus the square root of 3t plus 4 is equal to t plus the square root of 3t plus 4 times so you have to multiply the conjugate to the numerator and to the denominator. So this is what I'm telling class. So we have the limit of t minus the square root of 3t plus 4 over 4 minus t as t approaches 4. So if I'm going to rationalize this one, so I'm going to multiply this by its conjugate of the numerator. So we have t. So since it's minus, so we have to write there plus the square root of 3t plus 4 all over t plus the square root of 3t plus 4. Now if we're going to multiply that one, so the numerator is similar to this in our algebra. We have a plus b times a minus b is equal to a squared minus b squared. So applying these special products, so the answer for that is when you multiply by its conjugate, so the answer should be the square of the first term. So our first term is t, then we have to square minus the square of the last term, which is the square root of 3t plus 4 all over. Now in this case, we have to use FOIL method, but I will just write showing that we are multiplying. So we have 4 minus t times t plus the square root of 3t plus 4. Now simplifying that one, um, just attach here the word limit as t approaches to 4. Okay, so I will just write it here to make the correction. So the limit of that, the limit of t squared minus the square of t is t squared minus the square of this. We can cancel the 2 and the radical sign. So that is why we have the do not forget to write the quantity. So the quantity of 3t plus 4 all over 4 minus t times t plus the square root of 3t plus 4. So no need to multiply using the FOIL method. Anyway, we are just going to substitute the value of t as t approaches 4. So next we're going to use distributive property. So we have the limit of t squared minus 3t minus 4 all over 4 minus t times t plus the square root of 3t plus 4 as t approaches 4. So the continuation here on top. So we have the limit of, so the factor of t squared minus 3t minus 4 is equal to t minus 4. You have t minus 4 times t plus 1. All right, all over. I'm just going to copy the denominator. We have 4 minus t times t plus the square root of 3t plus 4 as t approaches 4. So in this case, we can now do cancellation. So we can cancel t minus 4 and 4 minus t. Take note, the orientation of the denominator is 4 comes first before negative t. So in that case, when you cancel that one, it's not positive 1, but instead it is negative 1. All right. So we have the remaining factors will be equal to the limit of t plus 1 over t plus the square root of 3t plus 4. Do not forget to write the negative 1, which is actually the quotient of t minus 4 over 4 minus t. So I will just write here negative in the middle of the longest bar, and then as t approaches 4. Now we are going to replace t now by 4. So we have the negative of, we have 4 plus 1 over 4 plus the square root of 3 times 4 plus 4. So we have the numerator now of negative 5 all over, we have 4 plus the square root of 3 times 4 is 12 plus 4 is 16. So the square root of 16 is 4. So we have 4. So the final answer now will give us negative 5 over 8. So that's the answer for this problem. So next we have, given the function of g of y is equal to y squared plus 5 if y is less than negative 2, then the other one is 1 minus 3y if y is greater than or equal to negative 2. So this kind of equation is what we call as a piecewise equation. So we are asked to compute the following limits. So the limit of g of y as y approaches to 6, and the limit of g of y as y approaches to negative 2. Now to do that, okay, so for letter A, we have the limit of g of y as y approaches 6. So you choose now which of these two equations that is according to this condition, that y is less than or negative 2, or y is greater than or equal to negative 2. Since our value of y here is approaches 6, so we are going to use this one, that if y is greater than or equal to negative 2, so we are going to use this equation since our y is greater than 6, because it said here that if y is greater than or equal to negative 2, then use the definition of g of y. So g of y is equal to 1 minus 3y. So in other words, class, for letter A, I will do like this. We have the limit of g of y as y approaches 6 is equal to the limit of 1 minus 3y as y approaches to 6. So I hope it's clear now to you why we are using this equation, because it says here that if y is greater than if y is approaching to 6, therefore y is greater than or equal to negative 2. So solving that limit, so we have what's the limit of a constant as y approaches to 6. So the answer there is a constant. So we have now 6. And what's the limit of negative 3y as y approaches to 6? So we have negative 3 is a constant. So the limit of y as y approaches to 6, so this is now equal to 6 because they're the same y, which is now equal to 6. So solving for that, we have 6 minus 3 times 6 is 18, and 6 minus 18 now is wait, why this is 6? This is not 6. It should be the limit of 1 as y approaches to 6 is equal to a constant. So the constant there is 1, not 6. So this must be 1. So again, the limit of 1 as y approaches to 6 is equal to 1. So we have now 1 minus 18. So therefore, this is negative 17. Okay, now for letter B, so which equation are we going to use if the value of y is approaches to negative 2? For letter B, class, so to do this part, we're going to remember the one that we studied on the one-sided limits. It says that if the two one-sided limits exist, so I'm referring right-handed limits and the left-handed limits. So if the two-sided limits exist, then the normal limit will also exist and have the same value. Now, this is what I'm trying to say, class. So for letter B, we have the limit of g of y as y approaches negative 2. So that is now the normal limit. So to solve for this, we are going to solve first the one-sided limit. So shall we say that the limit of the limit of g of y as y approaches negative 2 from the right. From the right means say greater than negative 2. So I'm going to use the equation of 1 minus 3y. So I will write here the limit of 1 minus 3y as y approaches negative 2 from the right. So to take the limits now, what's the limit of 1 as y approaches negative 2 from the right? So the answer there is a constant. This is now 1. Again, so the limit of 1, as y approaches to negative 2 from the right, so the answer is a constant. Now, the second term, minus the limit of negative 3y as y approaches negative 2 from the right. So, write first the coefficient, and then the value of y is negative 2, so times negative 2. So, therefore, this 1 plus 6, so that is now 7. So, on the other side, we have the limit of g of y as y approaches negative 2 from the left. So meaning to say, the y approaches negative 2 from the left, so we're going to assume the value that is less than negative 2. So since that is less than negative 2, so we're going to use this equation. Okay, so since the limit of g of y is approaches y approaches negative 2 from the left, meaning to say we are using the value of y that is less than negative 2. So therefore, this is what we are going to use. Okay, so therefore, we have the limit of g of y as y approaches negative 2 will be equal to the limit of y squared plus 5 as y approaches negative 2 from the right. Now, using the properties of limits, so therefore, we have here the limit of y squared as y approaches negative 2 from the right. So we have negative 2 to the power of 2 plus the limit of 5, which is a constant, as y approaches negative 2. So the answer is a constant. So therefore, this is now 5. So simplify that one. The square of negative 2 is 4 plus 5. Therefore, the answer is 9. Okay, since the result of the limit of g of y as y approaches negative 2 from the right and the limit of g of y as y approaches negative 2 are not equal, so the two values here are not equal or they are not the same, therefore we could say, okay, since I will just write here, since the values of two one-sided limits are not the same, then the limit of g of y as y approaches negative 2 does not exist. Okay, so that is how are we going to make the conclusion.